Number 4, evaluate the log of 2 log x over 2 to a base of 2 plus log of square root of x to a base of 2 to be equals to 8. Now the first thing we want to do in this problem is to bring this 2 to the up, okay, to be acting as an index. So this is simply equals to log of a base of 2 to x over 2. So this 2 will come to the up of this expression to be acting as an index, all to the power of 2 plus log of root x to a base of 2 to be equals to 8. Okay, now some of you might be wondering why I actually turn into that. I make use of some of the identity of logarithms, typically the one with a power, okay, the power identity of logarithms, which says that if you have a log of a certain base, let's say x to y, such that y has an index z, this z is allowed to come to the front of the logarithms and it will be acting as a whole number, such that it will be multiplying the log of base x to y. Now this can be done in the vice versa manner. If this is what I have initially, I can actually turn it to this, okay, I can actually bring this back, okay, to be acting as an exponent. So that's exactly what I make use of. Okay, so that is it. Now the next thing we want to do at this point is to expand everything we have over here, okay, and to do that all we need to do is to distribute the 2 for each and every value we have inside the parentheses. So this is simply equals to log of a base of 2 x squared, all divided by 2 squared is simply 4, then plus log of a base of 2 to square root of x to be equals to 8. Now the next thing we want to do at this point is to apply another identity of logarithms, typically this one, okay. Let me just make a clarification on it and show it out. I want to apply this product laws of identity of logarithms, which is that if you have a log of a certain base x such that you are having 2 different values to be multiplying one another, this can be equals to log of base x to y plus log of base x to z, okay. And one thing I like about the identity of logarithms is that they can be done in a vice versa way. Since this is what we are having initially, we can turn to this. If this is what you are having initially, we can turn to this. So that is exactly what I'm trying to say. So we're going to be making use of this identity at this point. So all we need to do is to take one log with the corresponding base 2 and multiply this and this together, okay. We just want to take one log and multiply those ones together, okay. So let's do that. So let me get rid of this. We don't have enough space, and I don't actually want to get rid of the question, so we're just gonna keep on managing the space. So we have log of a base of 2, so we have to multiply this and this together, okay. So that's simply x squared over 4 and multiply by square root of x over 1, okay. I just put it in a fraction to be equals to 8. Good. Now at this point we can actually apply the definition of logarithms at this point, okay, which says that this 2 is allowed to raise this 8. So 2 to the power of 8 can be indeed equals to x squared, okay, divided by 4, then multiply by square root of x, all divided by 1, okay. Now what exactly is 2 to the power of 4? At this point I need to make use of my calculator. So let me type in 2 to the power of 8 rather. So we have 256, okay, we have 256. So therefore left over at the left hand side we have 256. Let me write it properly. So we have 256 to be equals to x squared over 4, then multiply by square root of x over 1. Now in indices we are able to know that square root of x is actually the same as x to the power of half. So therefore we can replace square root of x with x to the power of half in this expression. Good. Now the next thing we want to do is to replace square root of x with x to the power of half. So we have 256 to be equals to x squared over 4, then multiply by x to the power of half. Okay. And the next thing we want to do at this point is to cross multiply. Okay, we just want to cross multiply, or we should just said we want to multiply both sides with 4 in order to get rid of the 4 that is associated with x. Okay, in this case, so all we need to do is to multiply both sides with 4. So therefore we're gonna have 256 multiplied by 4 to be equals to x squared over 4, then multiply by x to the power of half, then multiply by 4. Now to the left hand side or to the right hand side, 4 can cancel, and 256 multiplied by 4 is simply equals to what? 256 multiplied by 4, 1024. So we have 1024 to be equals to x squared, then multiply by x raised to the power of half. Okay, and the next thing we want to do at this point is to apply one of the identity of indices, which state that whenever you have a certain base in which the base turns out to be equals, you can just sum their power if those values are multiplying themselves. So therefore 1024 can be equals to x to the power of 2 plus half. Okay, we have actually applied the identity of indices at this point. So we have 1024 to be equals to, by the time we sum 2 and half together, that's simply x to the power of 5 over 2. Some of you might be wondering how it is equals to 5 over 2. What I did was that I find the LCM. Okay, 2 plus 1 over 2. Let's put this in fraction, that's simply 2 over 1. So to find the LCM, we can make use of 2. 1 in 2, that's simply 2, 1 in 2, that's simply 2. 2 times 2, that's simply 4. So we can just write our 4 down, and the sign we bring it back. Then 2 in 2, that's simply what? That's simply 1. Then 1 times 1, that's simply 1. So we write the 1. Then 4 plus 1 is simply 5 over 2, which is our final answer. And that is exactly how I got 5 over 2. Now the next thing we want to do is to solve for x. And to solve for x, we can just multiply both sides with an index of 2 over 5. With that, we will be able to get rid of the index that is associated with x. Okay, so to do that, we can just say multiply both sides by an index of 2 over 5. So we have 1024, that's 1024 raised to the power of 2 over 5, right, to be equals to x to the power of 5 over 2 multiplied by 2 over 5. Now it turns out that to the right hand side, 5 over 2 can cancel 2 over 5, and left over we have x to be equals to 1025 or 1024 raised to the power of 2 over 5. Okay, to make it simple and easier, you can just type this into your calculator to have a final answer. But what it means is that you are having the fifth root, okay, the fifth root of 1024 all to the power of 2. Okay, that's exactly the value of x. It turns out that the fifth root of 1024 is simply 4, and 4 squared will now be equals to 16. So definitely our final answer in this case will be in the equals to 16. So we have 4 squared to be equals to x, and 16 equals to x, which is final answer. And that is exactly how to provide the solution to this problem. Round 5. Try to pause the video and try to provide a solution to this problem. By the way, if you haven't subscribed to my channel, feel free to subscribe to my channel, and don't forget to give this video a like, as that is exactly what it tells you to do, that the video is liked so as to recommend it to many audience on their platform. Good. Now let's begin. Evaluate log of y to a base of 2 all raised to the power of log of y to a base of 2. Now we're still gonna apply the power rule, okay, the power identity of logarithms at this point. We said that if you have log of a certain base x to y such that y has an index z, this z can come to the front of the logarithms so that it will be multiplying the logarithms. So we can actually apply that to this point. Since it is y that is raised to the power of log of a base of 2 to y, definitely the whole expression here can come to the front of the logarithms, and that's exactly what we are going to make use of. So regardless of any problems you come across in logarithms, you just need to be calm and be very careful, as once you can do that, then definitely you should know the first step to 2, which is going to be the right step. So this can come to the front of the logarithm since it is raised to the power of y. Okay, so since it is an index of y. Okay, good. Now the next thing I want to do is just to bring this to the front. So that's simply log of 2 to y and multiply by log of y to 2 to equals to 25. Now it turns out that log of y to a base of 2 is multiplying itself 2 times, and whenever you have two different values or one value to be multiplying itself 2 times, it's going to become a perfect square. So log of y to a base of 2 times log of y to a base of 2, it becomes log of y to a base of 2 squared. So we have log of y to a base of 2, and all raised to the power of 2 to be equals to 25. Now the next thing we want to do at this point is to find the square root of both sides, so as to get rid of the square we have at this point. Okay, so doing that, we have square root of log of y to a base of 2 squared to be equals to square root of 25. Okay, good. Now log of this square can cancel the square root at the left hand side, and left over we're going to have log of y to the base of 2 to be equals to plus or minus 5, because the square root of 25 is equals to plus or minus 5. Okay, and the next thing we want to do at this point is to apply the definition of logarithms, as it is best easier for us to do that at this point. Good. Now let me get rid of this part so as to have enough space. Okay, so what says the definition of logarithm? It says it is a base to which an index is raised. So this 2 is allowed to raise whatever we have as our answer. So definitely 2 raised to the power of plus or minus 5 will now be equals to y. So when we have positive 5, 2 to the power of 5 will be equals to y, which is equals to 32, because 2 to the power of 5 is 32. And then when the value is negative 5, 2 to the power of negative 5 can also be equals to y. And let me make use of my calculator. 2 raised to the power of negative 5, that's simply 0. Negative 5 is 0.03 approximately, and that is the final solution to this problem. Now you know how to evaluate logarithmic expression. Now here's the last example I'm gonna discuss with you guys in this video. So what I want you to do is to pause the video and try to solve this problem. You know, practice make perfect. Just try to prove it out yourself as well. Okay, then after solving it, after giving it a trial, you can just try to check the video out. You get the point, either you are correct or not. So you know. Good. Now round 6. Evaluate the log of x to the base of 2 plus log of 2 to the base of x to be equals to 2.5. Now it turns out that the base of the logarithms expression we are having turns out not to be the same. So whenever you have a problem like that, here's what you need to do instead. You can just try to change the base of any of the one you wish to be the same, to be correspond. You can, if it depends on how you want it. For me, I'm gonna change the base of the expression over here to look like this, but for you, you can change the base of the expression over here to look like this. It depends on how you want it, and the one that you think will be much more easier for you to simplify. Alright, how did I want to change the base of log of 2 to the base of x to be equals to log of 2, or log of this 2 to x? How did I want to do that? To do that, I can actually introduce one of the identity of logarithms, typically the change of base. Okay, so I'm going to introduce the logarithm of a base of 2. Alright, so when I want to make use of the change of base identity, it depends on the base I want to make use of. Okay, so that will be equals to, since I want to make use of a base of 2, so that will be log of a base of 2. Okay, so the first identity I'm having, or the first value, that's 2, then all divided by the next one will be the log of a base of 2 to x. Okay, now it turns out that log of a base of 2 to 2 is equals to 1. So final answer in this case is 1 over log of x to the base of 2. So here's exactly what I'm going to make use of. So what I will do in this case is to replace this with this. Okay, so that's exactly what I'm going to do. Good, I believe you understand the point. If you didn't, check out the video that I just popped out. I showed and proved how this formula is true. So I'm gonna replace this with 1 over log of x to the base of 2. Good. So I'm gonna have log of x to the base of 2 plus 1 over log of x to the base of 2 to be equal to 2.5. Now at this point, let me say log of x to the base of 2 to be equal to y. Okay, so as to make my work easy and easier, such that it won't be somehow boring. I don't want to keep on repeating or rewriting log of x to the base of 2 continuously. Let me just set it to be equals to something simple. So therefore I'm gonna have y plus 1 over y to be equals to 2.5. Alright, the next thing is to find a way to change this 2.5 into a fraction. Whenever you want to change a decimal value into a fraction, here's what you need to do instead. What you need to do is just to shift the decimal until you have a whole number. Okay, now we have 2.5. To change it to a fraction, you can shift the decimal to the right. Once we shift it to 1 unit to the right, we're gonna have 25. But it turns out that 25 is a whole number, so we are good to stop at this point. So all we need to do next is just to divide by 10, since we just moved 1 unit to the right. If you move 2 units to the right before you get a whole number, you need to divide by 100. If you move 3 units, you need to divide by 1000, and so on and so forth. Hopefully you understand that. So therefore 2.5 is the same as 25 over 10. But it turns out that we can actually simplify 25 over 10 to the lowest term, as 5 can go in 25 in 5 places and 5 can go in 10 in 2 places. So the last or the least or the simplest form of the fraction is 5 over 2. So we want to replace 2.5 with 5 over 2. Good. So let me just get rid of this. So therefore we're going to have y plus 1 over y to be equals to 5 over 2. Alright, the next thing is to focus on the left hand side. Let's just find a way to turn the fraction. Okay, we just want to find a way to combine the like terms together, and to do that we can make use of the LCM. Okay, we can make use of the LCM to combine the fraction together. So this is y over 1 and this is 1 over y. Okay, so the LCM in this case can be y. Okay, so in how many different ways can we find 1 and y? So that's y places. Okay, so y times y is simply y squared. So we can just write our y squared. Let me make use of a very light color so that you will be able to see it properly. So we have y squared plus the symbol. Now in how many different ways can y go in y? That's 1 places. So 1 times 1 is simply 1. So y plus 1 is equals to 5 over 2. Now the next we want to do at this point is to cross multiply. Alright, we just want to cross multiply both sides. So once we cross multiply, that's why we come to this part and this will come to the part. So we have y squared plus 1 then multiply by 2, okay, to be equals to 5 times y. Alright, so once we expand this bracket, this 2 will be multiplying y squared, and at the same time it's going to be multiplying 1. So 2 times y squared is simply 2y squared, and 2 times 1 is simply 2. to be equals to 5 times y is simply 5y. Alright, the next we want to do at this point is to bring 5y to the side so as to have a trinomial, typically a quadratic equation. Then with that we will be able to solve for the value of y. So doing that we have 2y squared plus 2 minus 5y. How does it turn to minus 5y? Since it is positive 5y initially, once it's coming to the other side, it's going to become minus 5y. Good. And the next we want to do is to find a way to solve for y, since we are having a quadratic equation. Don't forget, it's going to be equals to 0. Good. So for me, I'm going to be making use of factorization so as to make things faster. However, you can make use of any of the choices you feel like. You can make use of any quadratic formula or completed square. But for me, I'm going to be making use of the factorization method. So let me actually rearrange this. So that's simply 2y squared, okay, minus 5y then plus 2 to equals to 0. Now the next thing we want to do when we are to make use of factorization method, we need two values that we will multiply them. It's going to give us the product of the first term and the last term, and the product of the first term and the last term in this case is simply 4y squared. And it turns out that we need to make sure that the value that we are going to make use of, once we sum the value, okay, it's going to give us the middle term, and the middle term we are having in this case is minus 5y. Okay, it turns out that minus 4y and minus y can be the best two values that we can use, as minus 4y times minus y is going to be equals to 4y squared, and minus 4y plus minus y will be equals to minus 5y. So therefore we can make use of them. So minus 4y and minus y. Good. Now the next we want to do is to replace the middle term with everything we have. Okay, so I want to replace this with this. Okay, good. So let me get rid of this for you to more space. Okay, so we're gonna have 2y squared then minus 4y minus y plus 2 to be equals to 0. Okay, the next we want to do at this point is just to group what we have. Okay, so to group it is very simple and straightforward. You just want to put them within the parentheses. Okay, that's simply 2y squared. Okay, so that's simply 2y squared. So minus 4y we group it, then minus y plus 2 as well, we'll group it within a parenthesis. And the next thing we want to do is to factor out the common factors. Okay, so it turns out that at this part 2y is common, so if 2y is common we can bring it out as a common factor. Okay, then left over we have y minus 2. Okay, and for the other part we have minus 1 to be common. So if minus 1 is common, left over we have y minus 2 to be equals to 0. Now we can just factor out the GCF, okay, the greatest common factor, so which is simply y minus 2. So therefore 2y minus 1 then will be associated with y minus 2, which is indeed equals to 0. Now at this point you can just set each of these parentheses to be equals to 0 so as to solve for the corresponding two values of y. So therefore for the first parenthesis 2y minus 1 will be equals to 0, or y minus 2 will be equals to 0. So therefore 2y will be equals to 1 once we bring 1 to the side. Okay, because it is negative initially, once it comes to that side it can be positive. So y will be equals to 2, since when 2 is coming to the side it's going to become a positive 2. Now the next thing we want to do is to solve for y for this part. To do that we can just divide both sides with 2. Okay, so as to get the value of y. I believe you're following. Good. So therefore y can be equals to 1 over 2 or 2. So those are the two corresponding values of y. Note, this is not our final answer. I hope you didn't forget this. We said let x to the base of 2 be equals to y. So therefore when y is equals to half, log of x to the base of 2 will be equals to half. And at this point we can actually apply the definition of logarithms, which says that this 2 can raise this half. So therefore 2 to the power of half can be equals to x, or when y is equals to 2 then log of x to the base of 2 will be equal to 2, and this 2 can raise this, so therefore x can be equals to 2 to the power of 2, and 2 to the power of 2 is simply 4, and that is the corresponding two values of x that we can have. Now you know how to easily and mentally evaluate logarithmic equations. I believe with this you should be able to handle any of logarithmic equations once you can just master the concept very well. Thanks for watching. I really appreciate it. Wish you all the best in any of your examination. So if you haven't subscribed, like I said earlier, make sure you do that now. So like I used to do, I have a gift for you, and that is simply an assignment. So if you want me to review your assignment, feel free to post it in the comment section below. I'm going to make a review on it and reply to it as soon as possible. Thanks for watching once again. See you guys in the next video. Essay to